Good morning to everybody. Today I will explain you kinetic energy. Energy possessed by the body due to its state of motion. In my last video I explained you the potential energy, that is energy at the rest. Now today energy of the motion, when an object is moving, for the motion energy is required. So in the motion energy is known as the kinetic energy. You know, mechanical energy is the sum of the kinetic energy plus potential energy. Now suppose object A at rest, when it was thrown to cover some distance, then this object become in motion. Now here point is to be noted that when the object was at rest, there was a hidden energy. As we saw that there is stored energy in the object, and you know stored energy, that is the potential energy. So as soon as it comes into motion, we say that this potential energy is converted into the kinetic energy of the motion. And the total, that is sum of the kinetic energy and the potential energy at a given moment, is equal to the mechanical energy. So we say if some part of the potential energy changes to the same part of the kinetic energy, then the total of two will remain same. Now suppose you are going somewhere on your vehicle, or suppose you are going on your scooter, some friends come to you in the opposite direction and try to stop you by applying the force in front of you. So some force is applied to stop your motion. That is opposing force. Listen, it is opposing force to stop the motion of your scooter. Then we say kinetic energy of moving body is equal to the amount of work done. Listen, kinetic energy of moving body is equal to the amount of work done by an opposing force to stop the body. Suppose a object is in motion and a force applied on the opposite direction to stop it, and during force applied, this retardation will be there and it will cover some distance. So retardation means acceleration will be negative. So if mass of the object is m, retardation is minus a, then distance covered is s, then the work done is equal to force into the displacement. This force is the retarding force. So this amount of the work done is equal to the kinetic energy as per the. So kinetic energy of moving body is equal to the amount of work done by an opposing force to stop the body. Now work done is equal to force into the displacement. Now force is the retarding force. Now here we have to calculate the displacement. Suppose the initial velocity of the object, that is u, is small v, and when it stops, final velocity is 0. Then from the third equation of the motion is v square is equal to v square plus 2as, and final velocity is 0. So 0 is equal to initial velocity v square. Now here retardation is minus a, then minus 2as. So 2as is equal to v square, then s is equal to v square upon 2. Now putting the value of the displacement here in the formula, I have into s, v square upon 2a, and you know force, that is m into a. m into a into b square upon 2a is cancel out, we get 1 upon 2 mv square. So this is the expression for the kinetic energy, that kinetic energy is equal to 1 upon 2 mv square. So this is the expression for the kinetic energy. Now we will explain what is the relationship of the kinetic energy to the momentum. You know, momentum is the product of mass into velocity. Is the product of mass into velocity. From this, we will find the value of v is equal to momentum upon mass. Now, putting the value of v in the equation, then momentum upon m square, that is 1 upon 2 m, momentum square upon m square, mm is cancelled out, then kinetic energy is equal to 1 upon 2 momentum square upon m, or momentum square upon 2 m. So momentum square is equal to 2 into mass into kinetic energy. So this is the relationship between the kinetic energy and the momentum. So remember, kinetic energy, that is energy in the state of motion, and it is equal to the amount of the work done by an opposing force to stop the body. And the expression become 1 upon 2 mv square. So I think it is clear to you. If you like my videos, please share and subscribe. Thanks very much.